We are now getting into an exciting part, exploratory data analysis. If you still remember, we talked about descriptive analytics, descriptive questions, and exploratory questions. They begin with the exploratory data analysis. As the name suggests, we want to explore our data. But why and how? The goal of exploratory data analysis is to develop understanding towards our data. In the last hands-on session, you have got an idea on how to check data quality, and now we move further to discover patterns, spot anomalies, test hypotheses, and even check assumptions. But how are we going to do this? Let's start from the two main approaches here: summary statistics and graphical representations. If you still remember, in schools, we actually learned about basic descriptive statistics. Generally, it is divided into two types of two purposes. One, to measure the central tendency, and the other one is to measure the dispersion of a list of data. Commonly, we use these measures to check each applicable column in our dataset. Measure of central tendency means to use a typical or a central value to represent the data. There are three measures, namely mean, which is the average, median, the middle value, and mode, the most commonly occurred value. On the other hand, measures of dispersion are to measure how dispersed or how scattered our data is. There are many measures that we can use to describe dispersion. Some examples are shown here, like standard deviation, variance, range, interquartile range, and so on. Usually, a higher value of dispersion means a more dispersed data. For example, when we compare between two data, the second data has higher variance than the first data. This means the second data is more dispersed or more scattered than the first data. Mean is the technical term for average. Average itself should be quite self-explainable to all of us, right? An example is here. These four values, 6, 3, 5, and 2, can be summed and then divided equally to 4 chunks, which resulted 4 for each chunk. Average is very commonly used to give the first impression about a data. For example, to investigate the credit card churn, we may ask, what is the average age of customers? What about the average age of those who have churned compared to those who will stay? Sometimes, an average itself can give us some initial insights or ideas. Next, mode. Mode means the most common values or category. Or we can say, the mode group has the highest count. For example, in a class, most of the students passed an exam compared to fail. Therefore, pass is the mode. Or another example, in a group, most of the members have height of between 160 cm to 170 cm. Therefore, 160 cm to 170 cm is the modal interval. Using central tendency alone to describe our data is not sufficient. We need to include dispersion measures too. Why? Let's look at these two data shown here. If we use only the average to describe the data, we are not able to spell out the difference between these two data. Why? Because these two data have the same average, which is 4. However, the distribution is different. Data 1 is more dispersed, while data 2 is more consistent. So how are we going to describe these differences? Using average is obviously not enough. We can include other measures such as standard deviation, variance, and so on. Here, let us see what are median, quartiles, percentiles, range, and interquartile range. Using central tendency alone to describe our data is not sufficient. We need to include dispersion measures too. Why? Let's look at these two data shown here. If we use only the average to describe the data, we are not able to spell out the difference between these two data. Why? Because these two data have the same average, which is 4. However, the distribution is different. Data 1 is more dispersed, while data 2 is more consistent. So how are we going to describe these differences? Using average is obviously not enough. We can include other measures such as standard deviation, variance, and so on. Here, let us see what are median, quartiles, percentiles, range, and interquartile range. All of us know mean and max, which are the minimum and maximum values respectively. The difference between these two values gives us the range. Let us arrange our data in an ascending order. Now, the first data has the smallest value, while the last data here has the largest value. We can split our data into fractions or portions, say like split into half, split into quarters, or split into other fractions. The threshold that differentiates each portion is called percentile. The illustration here shows the height of group of people, and they are queuing up in an ascending order. The shortest one is at the leftmost position, while the tallest one is at the rightmost position. If we split the people into half, the middle person here height becomes the median. So this person's height is 168 cm, which means that this is the threshold that distinguishes the first 50% which are shorter and the 50% that are taller. We can also call median as the 50% percentile. If we split the group of people into 4 portions, like shown in this illustration as well, the height of the orange color people are the cutoff line of quartiles. The first quartile is the threshold for the first 25% people, while the third quartile is the threshold for the first 75% people, or we can look from the other direction, which is the threshold of the tallest 25%. In this example, 25% of the people are shorter than or equal to 160 cm. In other words, 75% of the people are taller than or equal to 160 cm. We can also split our data according to other fractions to find any percentile. For example, split our data into 20/80 portion, then by allocating the 20% percentile, we can know the threshold that splits the data. Hence, 20% of the data are less than or equal to this threshold. Another measurement that we can use to identify dispersion is the interquartile range, or we call it IQR, which is we use the third quartile value to minus the first quartile value. For example, here the third quartile threshold is given by 175 cm, while the first quartile is given by 160 cm. Therefore, the interquartile range is given by 175 minus 160, so equals to 15 cm.